Hello, everyone. So in this session, we'll be covering model interpretability. So let's start. But first of all, I'm going to show you these different machine learning use cases. So on the left-hand side, you're seeing e-commerce product recommendations, image filters and enhancements, spam detection, social media feed ranking, real-time object detection. And on the right-hand side, for the use cases too, you're seeing credit scoring, health diagnostics, medical treatment recommendations, fraud detection, and hiring and recruitment. So off the top of your head, what are you seeing? What are the differences of the two use cases here? I would say the left-hand side would be would require more performance or accuracy in their outputs, whereas use cases two, we need more explainability. Of course, that's the intent of this session because it's all about interpretability. So in some tasks, getting the prediction, the what, isn't enough. The model also needs to explain how it arrived at that prediction, the why. So let's go back to the examples that I've given earlier. So on the left-hand side, it's about the what, and the right-hand side, it's about the why. So why is it that we have more emphasis on the model performance on the left-hand side? It is because these are well-established use cases. And even though we cannot, or even if we don't exactly give out the rationale for the decision to the intended audience, it still works. It's okay. Like when you use your filters in your phone, right, to enhance your images, do you really have to understand how it did that? You don't, right? Same goes on or the opposite applies on the other um, use cases here on the right-hand side. So there's more emphasis on interpretability. Like say, for example, credit score. If you are rejected or approved when you apply for a loan or credit card, you want to understand why. And it's also the responsibility of those institutions to explain to you how they arrived to that conclusion. And especially in the context of medicine, in health, right? You don't just blindly accept what the machine learning model will tell you. You also want to know why it led to that recommendation. So that's the reason why we need model interpretability. Again, not all these cases need interpretability, but a lot of also these cases that we have in industry would need interpretability. So how do we enable those when we create our machine learning models? Right. So we have two main approaches. First is using interpretable models, and then the other one is model agnostic methods. So for the interpretable models, we use models that are inherently interpretable, such as the linear and tree-based models. They're very straightforward. Whereas the model agnostic methods, we use these models because of their flexibility. We use them for non-interpretable models. And it is because they can apply to any model, even those as complex as deep neural networks.